these two compounds are termed as meso. Non-superimposable mirror image is enantiomers, and if they do not form mirror images, they will be diastereomers. So welcome back to our third class, and this class we will discuss the isomerism of organic compounds, and we will specially focus on optical isomerism because we are all very much habituated with normal isomerism or structure or geometrical isomerism. So here we will mainly focus with optical isomerisms. So a quick basics like that. So if you can see this compound, there are mirror image to each other, like this is the mirror, so the wedge and wedge, these all are mirror image to each other. Now if I twist the compound like this, it will form, or it will rotate 180 degree to form this. Now this compound you can see is exactly same of this one. So these two compounds are termed as meso. So we can say the compounds that are superimposable mirror image to each other. That means the mirror image can be superimposed on each other will be called the meso compound. And if this type of compounds, you can see this one, these two are mirror image also, but if I rotate it like previous time, this will form a structure like that. This structure and this structure is not identical. That means we can say if this is 1 and this is 2, so 1 and 2 are mirror image obviously, but not superimposable. They cannot be superimposed, so they are not superimposable, but they are mirror image. That means non-superimposable mirror image is enantiomers, and this compound, these two compound is not mirror image to each other, so there are no question of getting superimposed. If they are not mirror image, so they will not be superimposed at any cost. So these two compound are diastereomer. So here is the total part. If a compound is superimposable mirror image, that means it will be a meso compound. If the compound is non-superimposable mirror image, they will be enantiomers, and if they do not form mirror images, they will be diastereomers. So let's come to the questions part now. So in this question, what is said? They say that if we, in case X, for X, if we replace HA with D and HB with H, so it will be like this: CH3. We will replace HB with H and HA with D and nothing else. So this will be the compound X. And in case of Y, we will replace HB with D. So let's replace HB with D and HA with H, and these are the two compound. So this will be Y. Now the relation between them is being asked. So you can see if you put them, it feels like that D is the mirror image of D, H is the mirror image of H, but H and Br is not mirror image to each other. So we can clearly say they are not mirror image. They are not mirror image. So if they are not mirror image, they are obviously form diastereomers. Hence they will be diastereomers as they do not form mirror image. So this is a very easy part. Now let's come to the tricky one. Now this question is a little bit of tricky or complicated if we see it, but actually it is not. it is said that which one will be the most stable conformer. So we can see here in this carbon, this is second carbon and this is third carbon. So in number 2 carbon there is fluorine, 1 CH3 and 1 H, and in this case in the third carbon there is a CH2 CH3, a CH3 and a H. So second carbon has 1 fluorine, 1 methyl, 1 hydrogen. But here you see the carbon that contains fluorine contains the CH2 CH3 group, but this is not the case. So this compound and this compound is not same. Similarly, this and this, both the compounds are not this compound, because all in them the fluorine is attached with the CH2 CH3. The fluorine and the CH2 CH3 group is in the same carbon. You can see it. The fluorine and the CH2 CH3 group is in the same carbon. So this leaves only this structure. So among the 4, this will be the only feasible structure, and hence this will be the only stable structure. But if someone asks us or any question, if this is a sawhorse or flying wedge projection, so if someone asked us to convert this to Newman, how can we convert it? It is very easy. You can see, if we see from this direction, the fluorine is on the above, the CH3 falls on the left and the H falls on the right hand side. So this will be like this. There will be fluorine, there will be CH3 on the left hand side, and there will be hydrogen on the right hand side, and this bond will form on this line. So CH3 will be on the upper side, the hydrogen is on the right hand side, and the CH2 CH3 group will be on the left hand side. So this will be the Newman. Now we can easily rotate the behind bond or the back side bond and create different conformers. So there is no problem in converting a Sawhorse formula or a flying wedge formula into a Newman formula. It is very easy if you follow these steps as I have shown here. Now next problem. This is the third problem. This is also very easy if you can have already known the tricks. So the structure of S2-fluorobutane. So all of them are 2-fluorobutane. So we just need to figure out which one is the S conformer. We cannot determine R or S nomenclature from this type of structure, so A got cancelled in the first hand. Now doing RS nomenclature on Fischer projection is easy. So if we assign priority to the groups, fluorine will be 1, this will be 2, and this will be 3. So 1, 2 and 3, this goes back way, and this will be R. So this is not the S conformer. And in this case, for option B, fluorine is the 1, this one is the 2 obviously, and this one is the 3. So if we see from behind the H bond, we can see the fluorine is on the above, the CH2CH3 group is on the right hand side, and the CH3 group is on the left hand side. So fluorine to CH2CH3 to CH3, this will be an anti-clockwise, and this will be a clockwise rotation, and hydrogen is on the back side. So this will also be R. That means this carbon will also have a configuration of R. And now if we check this, fluorine is 1, this one 2, and this one's 3. If we see it again from the opposite side of the H bond, we can see fluorine like that, CH2 CH3 on the this side, that means C2H5 on the left hand side and CH3 on the right hand side. So fluorine, this 3 is anti-clockwise, and the hydrogen is behind the plane or far away from us. So this will be S nomenclature. So we can easily assign R and S nomenclature to all the carbons, and we can find out that the option C is the right answer as the S2-fluorobutane. Now if you want to know how we can easily assign R and S nomenclature that way. You can, if you do not want to know this, the tricks, short tips and tricks, you can ask me in the comment section and we will definitely upload a video on that tricks too. Now next problem, this one. This said that the Newman projection of meso 2,3-butane diol. Now meso compound is, if we are to isolate or distinguish or identify the meso compounds, Fischer projection is the better choice. But if we are given this Newman projection, we must remember one thing, that the anti-compound will always be the meso. So we just need to find out who among these are anti. We can clearly say that the P is anti. Why? All the groups are anti to each other. So obviously P is anti. So P will obviously be the answer, and either A or B will be our correct answer. So let's talk Q and R. Now in Q, Me and Me are anti, but OH or HH are in Gauss position. So this will not be anti. So Q is not anti. So let's come to R. We are seeing that all the compounds are Gauss to each other. So if we rotate this OH and the behind bond to clockwise 120 degree, we will find that this OH go to this position, this Me will come to this position, and this hydrogen will come to this position. Like if we rotate the behind bond for 120 degree, it will form a compound like that. The form, this one, the forward bond will be like this, and the behind bond, this OH will go into this position, this Me will come into this position, and this hydrogen will go to this position. So this is clearly an anti-structure. So we can say that R is anti. So we got that P and R, these two are anti-conformers, and anti-conformers are already meso. So P and R will be the meso compound, hence B is the correct answer. Now the last question for us will be this one. So this one is very easy. We just need to find out which among these 5 structures are chiral. So we all know, for a compound to be chiral, this must not possess a point or plane of symmetry. Now if any compound possesses a plane of symmetry, it will not be a chiral compound. So if we consider compound A1, there is a plane of symmetry. You can see these are the mirror image. Both the CH3 are on the below, and both the hydrogen is below the plane, so they are mirror image to each other, and this oxygen is above the plane, so it falls on the plane of symmetry, and hence this is not chiral. Once again, option 3 and option 4, they look like chiral, but this is CH2OH group and this is CHO group, so they are not chiral. So they are chiral. They do not possess any point or plane of symmetry. But this compound, both the group are same, so, and there is a plane of symmetry, so they are achiral, and this is also achiral. So 1 and 4 are achiral. Now we are seeing that the option 3 is chiral, so option 3 is one of the options. Now option 5, if we try to draw a mirror plane here, the O group falls on the plane, but both the CH3 are on the opposite side, that is, this CH3 is above the plane and this CH3 is below the plane, so there is no plane of symmetry in this case, so this will also be chiral. So you already got that 3 and 5 are chiral, but there is no option to check whether there is only 3 and 4. So 3 and 4 only comes with 2, hence B must be the answer. But if we want to check it, how can we check? We can draw a plane from this carbon to this carbon like this. So this CH2H, this CH2H will be on the plane of symmetry. So they will fall on the plane of symmetry. But this chlorine is like above and this chlorine is like going below. So they will not never be mirror image to each other. Hence this molecule is also chiral. We have already figured this out. So number 2, number 3 and number 5 are chirals. So this type of problems may come from this chapter, and we have discussed a couple of them, and I hope that you will be able to do them by yourself right now. So thank you for watching and all the best for the examinations.